Hi everyone, thanks for coming today to this webinar. My name is Chad Schmutzer. I'm a solutions architect with Amazon Web Services. I've been with AWS for a little over 4 years. I specialize in using EC2 Spot instances. So what I'm going to talk to you today about is a very popular workload these days, which is running containerized workloads, but using Spot instances for the underlying EC2 capacity. I think it's a very common and very useful workload. Allows you to save up to 90% on your containerized workload. So I'm going to go a bit into explaining, what Spot instances are, get a little bit deep into understanding how they work and some use case patterns. Learn about EC2 Spot best practices, right? So when it comes to using Spot instances, you really want to make sure that you have a good understanding of them, are comfortable with them, and understand how they can be utilized in your environment. So we'll take a moment to understand tools for managing Spot instances, right? So I'm going to show you some things about Spot instances, but I don't want you to just hear me talk. I want you to sort of come away with understanding how can I use them in my environment, what are some of the tools that I can use. And then we'll spend a few minutes going through an actual architecture and a demo of using containers on Spot instances, specifically the EC2 container service. But you can utilize the things that you'll be learning today about Spot instances in any sort of containerized environment that you're running. Once you understand how the Spot instances work in the Spot market and the tools that are available, they can be easily adapted to any sort of container management system. And then at the last 10 minutes, we'll save that for some live Q&A with one of my moderators, Boyd McGeeky. So hang around and please do submit some great questions for Boyd and the moderators to answer. All right, so let's get started. Just a quick review of the three different consumption models when it comes to EC2. The first being on demand, right? This is the utility-based purchasing model where you pay for your instances by the hour. You launch an instance, you pay for it, you shut it off, you stop paying for it, just like the electricity. Great for spiky workloads or as you're working through defining what your workload patterns will be. The second is reserved instances, right? So once you've locked in on what you need in terms of capacity for a given period of time, you can reserve instances, essentially reserve physical hardware in our data centers. And in exchange for that reservation, we give you a pretty significant discount over a 1 year or a 3-year period. And reserved instances are great for committed utilization where you'll be running workloads essentially 24/7 for that period of time. So the third consumption model, which we'll be focusing on today, is called the spot market. And this is a place where you can bid for unused capacity in our data centers. And it's great for time-insensitive, transient workloads, stateless workloads, but I think it's also a great fit for production-type workloads, especially in the case where you're running something like containers where you're already kind of operating in a transient place in terms of container services being launched. So let's jump into this a little bit, right? So AWS has a significant amount of spare capacity at scale. We have millions of customers running every month. We need to have capacity in our data centers to allow our customers to spin up and spin down workloads in real time. It's sort of what the cloud was made for. But what are Spot instances specifically in all of this capacity? So Spot instances are simply spare EC2 on-demand capacity with a couple of very simple rules. Right. So the first simple rule is that EC2 Spot instances run in a market where the price of the compute changes based on real-time supply and demand. So as instance capacity comes and goes, that triggers a fluctuation in the cost of the spot market, and that's all calculated in a real-time bidding environment. And we've made that available to our customers, right? The second simple rule is that you never pay more than what you bid. If at any point the market price does exceed what you have put a bid in, you don't have to worry. You're not going to be charged more than your bid. We will simply give you a 2-minute warning for you to wrap up your work on that instance, and the instance will be reclaimed by us. But at the end of the these are the two very simple rules that you will need to follow when understanding the spot market. And we didn't want all that spare capacity being left around idle, and so we've made it available in the spot market. And just following with these rules, you can get access to it in your own workloads. Right, so at the end of the day, spot instances are really the best value or the best bang for your buck when it comes to EC2 capacity. So what does that mean? Since spot instances typically cost 50 to 90% less than on demand, that unlocks a couple different scenarios. The first is that if you are in the need for additional compute capacity, you can simply increase your compute capacity anywhere from 2 to 10x, all staying within the same budget. By switching to using spot instances instead of on demand. The second is if you don't have a need for additional compute capacity, you're happy with the capacity that you're currently using, you can simply switch to spot instances and see an immediate impact in your savings, saving anywhere from 50 to 90% on your existing workload. Many customers will do a combination of both. Some will say, hey, I really would like to have some extra compute capacity, maybe for another dev test workload, QA, maybe doing some Jenkins jobs or something where it'd just be nice to have some additional compute. Other customers are, I'd really like to save some money on my bill. So combining both of these is still a fantastic way. So, give it a shot. Hopefully at the end of this webinar, you'll have confidence to go out and give spot instances a try. So in order to better understand how spot instances work, because they're so closely tied to our EC2 capacity, let's break down what capacity looks like in our data centers. So here I've chosen the Northern California region here just as an example, US West 1. In this very simple graph here, I have two availability zones being shown. I have some different instance types and then different instance sizes within those instance types. Right, so at the end of the day, every single one of these little rectangles you see on the screen is a separate pool of physical hardware capacity, right? So that means the physical capacity that is being used for C4 extra larges is separate than for C4 2 extra larges, which is separate than C4 4 extra larges. And obviously across availability zones, those are also separate. So when you start multiplying all those variables together, you come up with a lot of different capacity pools for you to pull from. And so that means each of these is a separate functioning spot market with different and fluctuating prices in real time for you to bid on. So again, understanding that if you can diversify your workload across a couple different instances or a large variety of them, both horizontally and vertically, you're going to be in the best position to get lowest cost and to acquire the capacity on the spot market. So let's just sort of recap what I just said from a pricing perspective, right? So I've got an example pricing capture from a point in time, right, for the C4 tier type of instances. So I've got on the left-hand side going all the way from large to 8 extra large, and then across the top the availability zones. And you can see that the prices are different both across instance sizes as well as AZs, because again, these are all separate spot markets. So if your workload is using a C4 2XL and it turns out that 2B, availability zone 2B got too expensive, you can simply switch to 2A or to 2C and use that to get the lowest price, right? So these are all, again, fluctuating in real time. You can see the static on-demand prices on the right. But again, if you look, you'll see significant average savings off of that on-demand price when you compare that with the spot market. So just to sort of recap that, each instance family, right, each instance size within those families, each availability zone in every single region is a separate spot market. All right, let's take a look and get a good understanding of bid price versus market price when it comes to running your spot instances. So if you only come away with one thing from this webinar, please come away with understanding that you never pay more than your bid price, but really you only ever pay what the current market price is. So when you put a bid in, you can bid much higher than the current market price, but you can see this green line here is a 1-week history of pricing for an R3 4 extra large in US East 1D. You can see that average price fluctuated around just under 18 cents per hour, right? So again, had you bid 75% of the on-demand price, in this case, the worst case is that you would have paid the on-demand price, but you can see that green line never even reached 75% of the on-demand price. So again, all that space between that green line and that 75% line is where the price can fluctuate and your instance is not reclaimed by us. So had you bid 75% of the on-demand price over a week's period of time, you would have only ever paid what that green line required, which was roughly 18 cents per hour. And your instance would not have been interrupted. It would have run for an entire week, again, with huge cost savings over that week's period of time. Right? So I like to say, just look, don't worry or focus too much on bidding. Just keep it simple and simply bid 100% of the on-demand price. Again, worst case is that you'd be paying the same as the on-demand price. Best case scenario is that you're saving 80 to 90% off of that on-demand price. And then that gives you some cushion in there for that price to fluctuate, with understanding that your instance will continue to run, only if that market price ever exceeded your 100% of on-demand bid price. All right, so let's talk a little bit about instance best practices when it comes to Spot instances. And what I really want to drive home here is that there's a ton of overlap when it comes to using Spot instances and just on-demand EC2 instances or even RIs, right? The first is you want your application to be designed in a stateless fashion as much as possible. You want to build in fault tolerance at the application level. You definitely want to take advantage of multiple availability zones or multiple AZs. And you want your application to be as loosely coupled as possible, right? So these are best practices, again, whether you're running on-demand or Spot instances when it comes to EC2. But the fifth best practice I will throw in when it comes to Spot is the ability to be as flexible as you can, right? So if you can consider using multiple instance types and multiple instance sizes, even if it's just a couple, you're increasing your access to capacity and lowest price while reducing any sort of risk for your application in terms of instances being reclaimed on the spot market. So if you're flexible and you've diversified your instances across multiple instance types, the likelihood that the prices will increase in both of them at the same time is extremely low. So just from a GUI perspective here, if you will, another best practice again is diversification. Typically customers will diversify either horizontally or vertically depending on their workload. So in the case of maybe, let's say, a web application that's sitting behind a load balancer, you want to maybe diversify horizontally, where you sort of say, let's pick instance types that have very similar performance characteristics and stick them all behind a load balancer. So in this case, we're choosing C3 large, M3 large, R3 large, C4 large, etc., etc. All of these will perform very similar from a web application perspective, and again, you're spreading your load across multiple instance types and therefore multiple capacity pools and multiple spot markets this way. Let's do a couple example customer use cases. First great one I like to reference when it comes to both Spot instances and containers is Mapbox, right? So Mapbox, they process those maps that you're viewing perhaps on your phone. They have many customers and provide access to looking at maps, and they need a lot of horsepower to process those and to cache those maps at edge locations closest to their customers. And so they're both utilizing ECS, container microservices, and they're also running those on Spot instances. And so they've sort of found that sweet spot where it comes to running microservices and containers on top of on top of Spot instances. And so they're sort of getting the best of both worlds when it comes to optimizing their capacity as well as their pricing. And if you want to read more about Mapbox, what they're doing in particular, they have got a couple of fantastic blog posts they've posted. One documenting on their journey to switching to ECS, and then how they're using Spot instances and what they call caches to cache, sort of a play on words by deploying their caching system on Spot instances. Second customer example use case is Yelp, right? Yelp has an internal distributed system they call Seagull for concurrent task execution, sort of an internal job queuing system for their internal teams to utilize. They ended up moving that entire infrastructure for SQL to Spot instances. Over that first migration to Spot, they saw a 55% reduction in cost after that initial transition. And then when they ended up adding auto-scaling into the mix, right, Spot Fleet with auto-scaling, they saw an additional 60% savings off of their total cost. And so that's a huge amount of savings, 85% savings simply by moving to Spot instances. And they spoke at reInvent last year, and it's a great use case where I think it shows a large-scale customer taking advantage of Spot in their environment. Okay, so I've just told you all these great things about Spot instances. Let me give you a couple of tools that you can think about using in your environment to take advantage of Spot instances, right? And that first tool is called EC2 Spot Fleet. EC2 Spot Fleet is a single API call that helps you launch, whether it's one instance or thousands of Spot instances, but all coming from a single API call, right? It's designed and has built-in allocation mechanisms. You can say, please go find the best price for me. I don't necessarily care which instance type I use in the type of instances you've allowed me to use. I'm just going to go find the lowest price out of all of those. Or it's going to be operating in a more diversified mode where it will try to balance your instances across availability zones and instance types as best as possible while still keeping price in as a major factor in its allocation strategy. And then finally, if you have cases where you are able to diversify vertically when it comes to your instance types, where you are able to utilize, let's say, a 2x and a 4x and an 8XL in your environment, those do provide different amounts of capacity when it comes to CPU and memory. So what you can do is you can apply something called custom weighting inside of a Spot Fleet to help let Spot Fleet understand that it is launching instances of different sizes and capacity. That way, your ultimate, let's say, virtual CPU count is what you have asked it to be versus just raw number of instances. We also have a couple of online tools to help you visually understand how the spot market has been behaving based on some metrics that you provide if you are after a certain type of spot instance or EC2 instance, and you wanted to see how that looked over the last week or month's period of time. This is just a URL. You can Google the EC2 Spot Bid Advisor, and it will return some numbers to help you understand the frequency of being outbid, over the past week or month. If you're like me and you like the command line, we also have an equivalent or equally powerful Python script that you can find in our GitHub repo, get spot duration. The GitHub repo will be linked in the presentation at the end of the webinar, and you can grab this Python script. And what it's doing is pulling the API pricing history and then providing very similar results to what you would have been looking at when it comes to history of spot pricing over the last month or so much period of time. Another tool we have in the console is called the EC2 Spot Advisor, which is a relatively new tool, sort of a graphical interface to allowing you to just sort of say, hey, this is my type of workload, whether it's a web service or a Hadoop job, a MapReduce job, Spark, or a batch type job. How much capacity do I need? Tell me what you recommend, and the Spot Advisor will spit out some results along with a JSON file that you can grab and then use to launch your Spot fleet, even with an estimated fleet price included with that. All right, so what types of workloads are customers running on Spot instances, right? So we're seeing all kinds. Queue and batch-based processing. Those are kind of no-brainers where you've got work being pulled from a queue and being processed. Stateless applications such as web tiers, a fleet of Spot instances behind a load balancer. CI/CD pipelines, we have a Spot Fleet Jenkins plugin that allows you to let your Jenkins server submit jobs to a Spot Fleet, and that Spot Fleet will increase and decrease in size based on the amount of jobs in the queue. Containerized workloads, right? This is what we're talking about today. And then live and even video on-demand streaming content are being done with Spot instances. So let me jump into containerized workload pattern here for a little bit, since that's what this session is about. So, right, containers are a natural fit for Spot instances. Right, so when you're saying, hey, my container management service, go find a home for my container, it's looking for resources, not instances specifically, right? It's saying, where can I find this much CPU, this much memory, this port, et cetera, et cetera. It's not tied to instances, and so that's sort of a very natural fit between the two services, or at least if you're using ECS, a very nicely, tightly integrated method. The second would be Spot Fleet's whole job is to really maintain a set of resources. And again, when you're thinking about containers, you just want some set of resources available to you. You don't necessarily care which instances are powering that environment underneath the hood. You just say, I need so much memory and so much CPU for my containers. Spot Fleet thrives on diversity. It really loves it when you let it launch different instance types and sizes and different AZs. And this just sort of further enables following EC2 best practices, where you're spreading your load across all those different types of instances and availability zones. And then finally, if you're in containers and using containers and microservices, you're probably already looking for the best bang for your buck when it comes to value. Well, Spot instances are going to provide you the best value for your EC2 capacity. So combining those two just makes a lot of sense. All right, so what are some things we want to consider for when it comes to architecting containerized workloads powered by Spot instances, right? You want to have good logging. You want to be able to see what's happening. You want to potentially receive notifications if an instance has been reclaimed. You'd like to sort of just get logs and metrics about that over time. What happens if an instance is going to be reclaimed on the spot market? You want to make sure that you can drain your containers off of that instance before it is reclaimed. You want to understand how to handle the Spot instance termination notice, right? That's a notice that we give you that an instance is going to be reclaimed, and it's going to play a heavy role in this architecture that I'm going to show you here in a second. And then you want to think about auto-scaling, right? You want to think about auto-scaling both your containerized service as well as the underlying EC2 capacity. In this case, we'll be using a Spot Fleet. So this is the architecture I'm about to show you. This is showing a region, 2 availability zones, and then a Spot Fleet that has been fired up to launch set number of instances. We're using CloudFormation to launch this entire environment. We're then using ECS, the EC2 Container Service, to manage our containerized environment. And then we're sending logs to CloudWatch logs, and we're also sending metrics to CloudWatch so that we can fire off things like CloudWatch alarms and trigger alarms to scale up and scale down our environment. I'm going to get out of PowerPoint and head on over to my screen. So I am now in the EC2 console. I've launched a couple of CloudFormation stacks ahead of time. Before I walk into my demo, I do want to point out that the console itself has native support for launching an ECS cluster directly onto Spot from the console, right? So you can find that here if you browse to Amazon ECS clusters, create cluster wizard. You can see that in the provisioning model, Spot is now an option. And so you can fill in all of those details that I was mentioning earlier when it comes to allocation strategy, the different instance types that you would like to use in your ECS cluster, the maximum bid price per hour for your instances, how many instances you would like, your AMI, et cetera, et cetera. So very comfortable and very easy way to get started using ECS on top of Spot instances. I happen to like CloudFormation, so what I'm going to show you here is an equivalent launch of an ECS cluster on Spot instances, but using CloudFormation. And this CloudFormation template has been published in our GitHub repo, the AWS Labs EC2 Spot GitHub repo, and that will also be linked at the end of this presentation as well. So in this case, what I'm doing here is I'm requesting a Spot Fleet. I'm asking Spot Fleet please launch the number of instances that I've decided I need initially in my ECS cluster or for my in my environment. I'm setting up an entire VPC and subnets and all of those things just so that I can keep this separated from the rest of my environment. I'm setting up security groups so I can shell into the instances to just sort of get a check on what's happening. I'm setting up a Spot fleet, and I'm giving instances that are launched via the Spot fleet specific permissions. I'm giving them IAM instance roles, allowing them to take action, to do things like logging and to do things like sending alarms when an instance is going to be reclaimed. So all of that will be coming from these instances directly, and those permissions have been granted to the instances that are running in my ECS cluster. We're also going to drop a monitoring script that we will call the Spot Instance Termination Notice Handler. And this script is a very simple while loop, but what it's going to do is it's going to loop, sleep for 5 seconds, check to see if a termination warning has appeared. If it has, it will put the container instance into draining state, which will trigger a draining of containers off of that instance. And then it will simply send some logs to the logging mechanism, and then it will publish a notification to an SNS topic, the simple notification service, and that's about it, right? So it's not complex, but just sort of understanding how to capture this and take action is really what I would like to explain to you today when it comes to using Spot with containers, or I should say containers with Spot. Okay, so this is what this CloudFormation template looks like. It's not terribly complex. Again, it's in our GitHub repo. You can link to it at the end of this session in the deck. So let me now show you what has happened. So I've launched this CloudFormation template. It is called the ECS demo. I can see some of the outputs that it has given me. I've got an SNS topic. I have an ECS cluster, a CloudWatch logs group. I've got my Spot fleet request ID, etc., down the line. All right, so let's take a look at our ECS console. So I've got 3 clusters running in here. One of them is called ECS demo. You can see it has, let me just refresh just to make sure this is current. You can see it has 4 container instances running inside of it. And these 4 instances are Spot instances that were launched by Spot fleet. So if I go back here and I look in my EC2 console and look under Spot requests, you can see I have a Spot fleet request here, C22, and it has 4 instances, right? So these instances are the 4 instances that are now joined into my ECS cluster. And you know, your ECS cluster at the end of the day is just simply a number of EC2 instances. So this could even be a combination of on-demand and Spot instances if you chose, or even RIs. So there's nothing preventing you from mixing and matching instances, procurement instance types within an ECS cluster. All right, so let's take a look at what else is happening here. I've got CloudWatch logs. I've got my logs coming out of my cluster, my demo cluster, into CloudWatch logs, so I can get a consolidated view of what's happening across my cluster. So I'm sending things like var log messages, the ECS agent log, etc., and any other custom logs you'd like to send. And then I've got an SNS topic set up that is, is able to be published to. So if I wanted to subscribe myself to this, I could get alerts when an instance is reclaimed and replaced in my Spot fleet. So anyhow, let's take a look at how this works. Let's launch a service on our cluster and then kill an instance, right? We'll take an instance away, sort of emulating what Spot, let's say an instance was reclaimed by the Spot market, and we will watch how ECS handles this by coupling this script and the ECS cluster together. So let me look at my task definitions. I have a task definition that simply launches the Nginx container from Docker Hub. So I'm going to say create a service. I'm going to choose my ECS demo. Let's call this Nginx. let's ask for 4 tasks, and we'll leave everything else to be default, 50% healthy, 200% min healthy, and 200% maximum healthy. And let's just go ahead and launch this, right? So what we've done is we've said, please launch 4 containers onto my ECS cluster. And so let's go back and see how that's going. Help if I went to the clusters tab here. All right, so I can see I now have 4 running tasks in my ECS cluster. I've got 4 container instances. If I drilled, and 1 service, and that 1 service has now launched 4 tasks. If I drill down and I take a look at it from a tasks perspective, you can see that I've got these 4 tasks running. If I look at instances, I have these 4 EC2 instances running inside of my ECS cluster, and each of these instances is running a task, right? So I've got 1 task running on each instance. So now let's pretend that the spot market has reclaimed one of our instances, and I'll just fabricate that by simply going to the console and reducing the size of my target capacity from 4 to 3. So I'm going to tell Spot Fleet, remove one of my instances. And this is the same thing that happens when an instance is reclaimed with a spot market. If it happened from the spot market, Spot Fleet would detect it and replace it. In this case, I'm doing a simple decrease in capacity across my Spot Fleet. So what we'll do is we'll watch this here for a few minutes, and we will see that that instance is going to be shut down by Spot Fleet, and that script that's running. Let me shell into one of these instances here and show you. So this is one of those 4 instances that I've launched. Is currently running Nginx, and I have this watcher script running on it. Show you what that looks like. Right, so this is the watcher script that I showed you in my CloudFormation template earlier. It's simply a while loop that's looking to see, does this termination warning exist termination notice exist in my metadata. If it does, tell ECS to put my container instance into a draining state, send some logs to CloudWatch logs, and then publish to my SNS topic that, hey, I'm going to sleep. I'm vacating instances off of containers off of this instance, and goodbye, essentially. So let's look here. This is going to take a few seconds here for this thing to go into draining state. We'll take a look to see how Spot Fleet is doing. All right, so Spot Fleet is still shutting off one of my instances. Hopefully I told it to modify that. Yep, okay. It will terminate the instance here in a second. And once that happens, the CloudWatch, termination warning script will catch that, and it will tell this instance to go into a draining state. Yep, there it goes. Right, so we caught the termination notice. We put this instance into draining. That task that was running on it has been migrated to another instance, right? So I didn't lose net number of tasks. ECS simply said, okay, an instance is going away. I will replace this task and launch it somewhere else, and then this instance won't accept any new tasks from that particular service. Had this been a real reclaim by Spot Fleet would have simply tried to replace that instance with another instance and then joined it back to the ECS cluster, so your overall capacity would have been available to you. So I hope that this has been valuable. I hope you come away with a better understanding of how you can power your containerized workloads with Spot instances. Again, at the end of this deck here, which will be published on SlideShare, you can get links to our GitHub repo as well as a blog post for powering your ECS cluster with Spot instances, and a workshop you could run through if you want to learn a little bit more just about ECS and Spot Fleet in general. So again, thank you everyone. I really appreciate you spending the time with me today. Hang on here for some Q&A, some live Q&A, and thanks again for your time. Don't forget to fill out the evaluation for this webinar session. Take care.